We are going to look at solving systems of equations algebraically. The first way we looked at solving systems was graphically, and next we're going to look at elimination and substitution. Elimination. You can use the addition property of equality to solve a system by the elimination method. You add equations to eliminate a variable. Same variables must be lined up to use the elimination method. If you look at example 1, you'll notice that the x's are lined up, the y's are lined up, and the equal signs are lined up. So therefore, we can use the elimination method. You might also notice that the x's have the same coefficient, just opposite signs. So if I add these two equations together, 6x plus negative 6x is 0, so that eliminates. Negative 3y plus 5y is 2y, and 3 plus 3 is 6. Then if I divide by 2, I get y equals 3. So there's one of my solutions. So then I have to go back to one of my original equations, plug y in, and solve for x. It does not matter which equation you substitute your value in for. I'm going to choose the first one. So the first equation said 6x minus 3 times y, and we found that y is 3, equals 3. And then solve for x. So 6x minus 9 equals 3. Add 9 to both sides. So 6x equals 12. Divide by 6, we get x equals 2. So my solution here is 2, 3. Same idea number 2. So our x's are lined up, our y's are lined up, equal signs and numbers. However, we notice that our x's same coefficient but same sign. So if we add them together, I would get 10x plus 9y equals 56, and nothing eliminated. So therefore, what we can do is we can multiply an equation by any number we want as long as we do the same thing to every term. So I'm going to multiply the second equation by -1. If I rewrite the first one, just so they remain lined up, and the second one, when I multiply by -1, I get negative 5x minus 6y equals negative 34. Now I have same coefficient, opposite signs. And if I add them together, my x's eliminate. I'm left with negative 3y equals negative 12. Divide by negative 3, you get y equals positive 4. Again, once we get one of our answers, I go back to an original one. So let's say the first one. So I have 5x plus 3 times 4 equals 22. And then solve for your other variable. Subtract 12 and divide by 5. So then my solution here is 2, 4. Alright, let's look at some more elimination examples. Alright, so number 3, variables lined up and equal signs and numbers. But I look and I don't see any of the same coefficients. The x's, we have a 3 and a 4, and the y's, I have a 10 and a 40. So then we need to see what we can multiply one of the equations by to have the same coefficients but opposite signs for one of the variables. So going back to the y's, you might notice, okay, I can multiply 10 by 4 and get 40. One will be negative, one will be positive. So let's multiply the first equation by a positive 4. When we do that, we get 12x minus 40y equals negative 100. And then the second equation we're going to keep the same. So 4x plus 40y equals 20. All right, and if we add these two together, we have 16x, the y to eliminate, equals negative 80. So then divide both sides by 16, and x equals negative 5. All right, so let's go back to one of our originals. So let's choose the first one. We'll have 3 times negative 5 minus 10y equals negative 25. And then solve for y. So take negative 15. Add 15. So we have negative 10y equals negative 10, which means that y equals 1. So our ordered pair here, negative 5, comma 1. So it doesn't matter which variable you solve for first. You just have to make sure you solve for both variables. All right, let's see, number 4. Okay, so A's lined up, B's lined up in equal signs. We don't have any of the same coefficients. But I noticed for my B's, let's see, the first one has a 4b, second one's a 1b. So I could multiply the second one by negative 4. So keeping the first equation the same. And when I multiply the second one by negative 4, we get negative 20a minus 4b equals 28. Then we're going to add these two together. So negative 18a, our b's eliminate, equals 36. Divide by negative 18, so a equals negative 2. Then we substitute that negative 2 back into one of our original equations. So let's go with the second one this time. We'll have 5 times negative 2 plus b equals negative 7. Take negative 10 plus b equals negative 7. Add 10 to both sides. B equals positive 3. So when I want to write my ordered pair this time, we do so alphabetically. So we'll put our A value, comma, our B value. All right, let's look at 2 more examples using the elimination method. So in number 5, our variables are all lined up, and then we look at our coefficients, and there's nothing I can multiply one equation by to get my variables to eliminate. So then we look at multiplying both equations by different numbers to get our variables to have the same coefficient but different signs. So it doesn't matter which variable we eliminate, but looking at the C's, 3 and 5 have a common factor of 15. So I can multiply the top one by 5, the bottom one by negative 3. So when I do that, I get 15C plus 25D equals 50, and negative 15C minus 21D equals negative 30. All right, then let's add these two. So C's eliminate. I have 4D equals 20. Divide by 4, we get D equals 5. So then let's look at, we'll use our first one. So substituting 5 in for D, we have 3C plus 5 times 5 equals 10. So 3C plus 25 equals 10. Subtract 25. 3C equals negative 15. So C equals negative 5. And when we list our ordered pair, do so alphabetically. So it'll be negative 5, comma, positive 5. All right, let's look at number 6. All right, same idea. Variables lined up, but there's no number I can multiply one equation by. So we'll look to multiplying both equations by different numbers to get same coefficient, opposite signs. Looking at my y's, I already have opposite signs, so I'm going to choose those. So the first one, if I multiply by 3, second one by 2, see, then we get 9x minus 6y equals 30, and 4x plus 6y equals negative 4. Add these two together. See, we have 13x equals 26. Divide by 13, x equals 2. So I'm going to go with the second equation this time. So of 2 times 2 plus 3y equals negative 2. 4 plus 3y equals negative 2. Whoops, I'm ready to write my answer here. All right. Then I subtract 4 and get negative 6. Divide by 3, so y equals negative 2. So my ordered pair, 2, comma, negative 2. The last method you could use for solving systems of equations would be substitution, which is replacing one quantity with another of equal value. So the substitution method for solving systems of linear equations means we're going to replace one variable with an equivalent expression containing the other variable and create a one variable equation that can be solved. So you might notice right away that our examples are set up a little differently. In number 1, y is by itself in the first equation, and x and y are together in the second one. Whenever you have one variable by itself, substitution method is easiest. So y equals 2x. I can take this 2x from the first equation and substitute it in where y is in the second. So my second equation will now read 7x minus 2x equals 15. Now I have an equation with one variable I don't know. So if we combine like terms and divide by 5, I get x equals 3. So then go back to one of your originals. In this case, I'll go to the first one. Y equals 2 times what x is, or 6. So my ordered pair is 3, comma, 6. A similar idea, number 2. So y is by itself in the first one and the second one. So I'm going to take what y is in the first one and substitute it in for y in the second equation. So I'll have negative 4x plus 8 equals x minus 7. And then we have an equation with one unknown. So let's subtract x. And we have negative 5x plus 8 equals negative 7. Subtract 8. Negative 5x equals negative 15. So therefore x is 3. Now I'm going to use the second equation here just because it looks a little easier. Because y will be 3 minus 7 or negative 4. So my ordered pair is 3, comma, negative 4. All right, and here are our last two examples using substitution. So number 3, in the second equation, y is by itself. So we're going to take that 1/2 x plus 4 and substitute it in where y is in the first one. So rewriting my first equation, I have negative x plus 2. Then I'm going to substitute in for y. I need parentheses here. And so y is 1/2 x plus 4. And then we finish the equation, equals 8. Because the first equation, it said take 2 times what y is. So that would be the whole thing. All right, now let's simplify. So I get negative x plus 8. Whoop, almost wrote a 2. equals 8. Combining like terms, my x's add up to 0. I'm left with 8 equals 8. So remember, when your variable eliminates and you have a true statement, we call this all real numbers. It's also known as the identity, or all real solutions. Also known as infinitely many solutions. All real numbers can be abbreviated with the capital R. Okay, and our last one, number 4. All right, so again, let's take what y is from the first one and substitute into the second one. Let's see, well, if negative 4x plus 4x plus 3 equals 2. All right, let's combine like terms. So negative 4 plus 4 is 0. So I have 3 equals 2, which is not true. So number 4 is a no solution. Our variable is eliminated, and we're left with an untrue statement. Nope, just no solution. There we go.